Welcome to the ET380 how-to video for our active filters lab. Here's our low-pass active filter circuit. Let's go ahead and take a look. Okay, here's our circuit in multisim. Let's grab our oscilloscope. We're going to need a ground. And let's go ahead and check our output. And let's go ahead and use our adjuvant function generator since it allows us to move those frequencies around. So let's go ahead and start it. And let's get this up to 10 volts. Good. Whoops, come on. There we go. Let's go to frequency. And what we're looking for on our scope is 0.707 volts. Okay, let's go to measure, make it easier for us. Peak to peak. And we have 13 volts. Okay, we're still at 10. Let's go back here to amplitude. Do we have, yes we do. Let's check our frequency. And let's start going up. And immediately we drop off. So let's go ahead and open this up a little more. And let's start dropping back down. See, we'll get that back up there to 10. Alrighty there. See if we can get it back to 7. And let's get this down so we get accurate. And it's not going to let me do that, so we got 7.36. So let's go ahead and go to frequency. So we got 1.4 kilohertz is our cutoff frequency, or close to that. Here's a close-up of our oscilloscope showing that we have 1.4 kilohertz. And I go through our calculation here and I come up with 1447 hertz. So it's perfect. Okay, so we used our old school. Let's try going to our other method of using the Bode plotter. So let's go ahead and we're going to need an AC signal generator. And let's grab a ground. And let's grab our Bode plotter. Need a couple grounds. Whoops. Let's go to our output. Let's see if we get the same reading we did. So let's go ahead and start the simulation. Come on. There we go. And let's change that to megahertz. Hertz. And that is one weird output. Let me see here, what do we got here? Out, in, log, we got it. Let's see what's going on here. Let's go ahead and turn this off and reset it, see if we get a better output. Oh, that's a 1 hertz, so let's get this way over. And there we go. We're out 1.462 hertz, so it is the same. Here's our circuit for our high-pass active filter, and let's take a look at it in multisim. Here's our high-pass circuit in multisim, and let's go ahead and add our Tektronix oscilloscope. We need a ground. And let's go ahead and tie in our scope. And we need our adjuvant function generator. Good. Let's start our simulation. Make sure turn on our function generator. Make sure it's at 10 volts, and it is not. Be careful I don't overshoot it. Come on. Okay, let's go to frequency. Turn on our scope. Spread it out a little bit. Let's go to measure. And let's check our peak to peak. Okay, we're in the ballpark here, so let's see if we get 7 out of this. Okay, I'm going to call that good. And let's go ahead and grab our frequency on our 1.1 kilohertz. And let's see if we can dial that in a little more. And he just doesn't want to behave, so we're going to call that good. Yeah, I'm going to call that good. Okay, here's a close-up of our oscilloscope, 1.1 kilohertz, which matched our Bode plotter. And my calculation is 1026 hertz. We're in the ballpark. Looks good. Okay, here I am at our multi-sim adjustable notch filter, and I'm going to start our simulation. I am using our Tektronix scope, and I am using our adjuvant function generator. So let's turn it on, make sure we have a sine wave. Should be 10 volts. Let's go to amplitude. Okay, and let's go to frequency. All right, so let's take a look at our scope here, and let's bring down our amplitude on our scope and spread it out. Start our measurement. We want to go to frequency, peak to peak. Okay, so there we're at 9, so we're getting close. So let's start going down until we get to our 707. And we're right there, and that we got 730 hertz. And I believe that's our top. So let's go to our, keep going down, see if we can find the bottom. And we've got to keep going, looks like. All right. Let's shrink this up. There we go. Should be around 600 if I could get it dialed in. Let's restart our scope here. Yeah, we got an error. Let's restart it, see what we got. There we go. Yeah, sometimes it out calculates it, so it should be around 600. So what's going on here? There is 630. I'm going to call that good, and looks like our lower frequency is 590. Good. Okay, back again at our multisim, and I replaced our oscilloscope and function generator with a Bodhi plotter. Unfortunately, I forgot to add a AC or a sine wave here, so we're just going to go ahead and add it right now. And before I change the pot, let's go back in and double check our first answers that we had. And let's start our simulation, open up our Bodhi plotter. And since we're close, let's go to 1,000 hertz. Let's go to 1200 here. Oops. 1200, and our initial value, let's go 450. And what I'm doing is trying to dial in. And let's go ahead and restart it. In, out. Okay, so let's, 0 dB is fine, so let's go minus 12 dB. See if that'll, there it is. Okay, so now we're seeing our notch filter. Alrighty, so let's move our cursors here and see if we get 3 here on this bottom piece. Close enough right there, and 593. I came up 590, perfect. And let's move this over to the other side of our notch here, and good. We got 3 and 733. Perfect. So these two matches. Okay, here we're back at our notch filter, and I got our Bodhi plotter with our function generator, and I set our pot at 50%. So let's turn our simulation, open up our Bodhi plotter, and I guessed at 10 kilohertz and 1 hertz, and I do get our notch. So I'm going to go ahead and set this at minus 20. And I had to play with this a while in order for it to okay, so let's go ahead and move our cursor. Oops, come on, come on. Close enough. So what do we got here? We got a 200 hertz. And on the other side we have at 3 dB, oh, close enough, and we got 2.2 2 kilohertz. That looks good. Okay, back again at Multisim, and let's go ahead and turn our simulation on, off and on, and let's hit our A key and run our pod up to 100%, and let's turn it on and off and see what kind of, oh, we're still in the ballpark. So let's go ahead and go to 3 dB on our Pody plotter, minus 3D. Close enough. We're at 116 on the low side. And let's go to our high side here. Minus 3 dB. Close enough right there, and it is 5.6K. Good. I think we got this one.